Good morning. In this exercise we are going to in this slide we are going to see exercise 2.1 ninth question. Okay, in the ninth question what they are asking to do, if A vector, B vector, C vector are three perpendicular unit vectors, then prove that modulus of A vector plus modulus of A vector plus modulus of C vector is equal to root 3. It is also a very easy question. Since they are asking to do 3 vector and modulus and root 3, we need to prove as root 3. Just take given vectors that A vector and B vector are mutually perpendicular unit vectors, and then if they are mutually perpendicular to each other means then A vector dot B vector, B vector dot C vector, C vector dot A vector is equal to 0. So then take the A plus unit identity formula, A plus B plus C the whole square, that is A square plus B square plus C square, plus 2 times A dot B, B dot C and C dot A. So since all are unit vectors, next step you can easily understand that 1 plus 1 plus 1, and then this A dot B and B dot C and C dot D, C dot E are equal to 0. So everything is 0. So that whole term will be 0. So obviously it is 3. Since the whole square is 3, then if taking square root on both sides, obviously we will get A vector plus B vector plus C vector is equal to root 3. It is easy, right? Now see the next question. This one is also easy. A plus B is equal to 60, A minus B is 40 and B is 46, and we need to find modulus of A vector. Solution: since they given A plus B and A minus B, we are taking a formula from that. We know that A plus B whole square plus A minus B whole square is equal to 2 times of A square plus B square, right? So that's why we are just taking this formula and squaring on both sides, squaring the terms. So now in the next step you can see that 60 square, A vector minus B vector is 40, and then A square plus B square, and you just take it as a vector, it is not cap, all this 2 is vector. That's a mistake. Okay, now 60 square, 40 square, you know how the values came. Next step, I'm just bringing 60 square 2 into the right hand side, it will be 1 by 2. 60 square is 5600 and 40 square is 1600, and then keeping modulus of A square plus 46 square. 46 square is 2116. Next step, adding 5600, 1600, and then subtracting, dividing by 2, we will get 2600. You can work it out, and then bringing the 2916 to right hand side, it will become minus. So when we subtracting, it is 484, and square root of 484 is 22. Therefore modulus of A vector is 22. That's it. Now question number 11. We have U vector, V vector and W vector. We vector that sum of the vector is equal to 0, and also they given a value modulus of V vector is equal to 3, modulus of V vector is equal to 4, and the modulus of W vector is equal to 5. Then we need to find U vector dot V vector plus V vector dot W vector plus W vector dot U vector. See how can we do. Since it is equal to 0, we can take the same formula A plus B plus C the whole square and then apply the values. That's all. It's very simple, right? Modulus of V vector is nothing but U, right? So it is 3. Modulus of V vector is nothing but V. Modulus of W vector is nothing but 5 W. So 3 square is 9, 4 square is 16, and 5 square is 25. We don't know the rest of the things, so just keep it as it is. And next step, adding these values, it is equal to 50, and then take that 15 to left hand side, it will become minus 15, and interchange the place. So we are getting 2 times U dot V vector plus vector V plus vector W plus vector W dot vector V. is equal to minus. If you bring the 2 to one side, it will become minus 25. That's the answer for the 11th question. Now see the 10th question. It is very easy actually. Show that the vectors form a right angle triangle. First of all, let's see that whether it forms a right triangle. We know the rule, right? So take A, B, C, and then we see that some I plus 2 is 3, minus 3i plus j is minus 2j, and 5k minus 4k is k vector. So A vector is equal to B vector plus C vector. So it says that A, B and C are form a triangle. How we know this property, right? B and C. So B plus C is equal to the A vector. So A vector is equal to B vector plus C vector. Further, find A vector at C vector. Since it has to be right angle triangle, we need to go there. So A vector at C must be 0. So product of that is take A value and C value. So on product, 3 into 2 is 6, minus 2 into 1 is minus 2, 1 into minus 4 is minus 4, and then solving it, it is equal to 0. If it is equal to 0, it is A vector is perpendicular to C vector, then the vectors form the sides of a right angle triangle. Now question number 13. And same thing, but we have question vectors here, so take it as OA vector and OB vector and OC vector. Then find AB vector. AB vector is nothing but OB vector minus OA vector. So subtract OB and OA, we will get this, and then take modulus. And similarly, BC vector, CA vector. You can work out it. It's very easy sum. And then you can see that if you square if you square any two of this one adding, we will get the third result. Likewise 21 14, right? If square of 21 is 21, square of 14 is 14, so 21 plus 14 is 35, that is square of 35, right? So like that you can say that hence BC square is equal to modulus of AB square plus modulus of vector CA square is equal to 35. Right? It is a, what is the formula is this one? It's a Pythagoras, right? So yes, the points form a right angle triangle. So that is the question number 13. Now question number 14, that is very easy. Find the projections of. So we already know that projections formula, right? So using that formula we can easily find the answers. That's it. First one, take A vector and B vector as k vectors, since they are telling on z axis. So z axis is k vector. Just take it as a k vector. That is a component of z axis, right? So projection of A vector on B vector. This is the formula. A vector on B vector is A vector dot B vector by modulus of B vector. So next step, A vector dot B vector is equal to 0. Why? In A vector there is no k components, but in B vector there is a k component. So we cannot multiply. Why we multiply? We get 0. Therefore A vector dot B vector is equal to 0. Obviously projection of A vector dot B vector is 0, because A vector dot B vector is equal to 0, right? So 0 by anything is 0. So the required projection is 0. Now see the second question. Take A vector and B vector as values given. Now find what is the projection of A vector and B vector. The projection of A vector and B vector is A vector dot B vector by B vector, modulus of B vector. So here we have some values. So we can find the A vector dot B vector straight away. Multiply 1 into 2 is 2, 2 into minus 1 is minus 2, and minus 2 into 5 is minus 10. So finally we will get 2 minus 2 minus 10. Here it is modulus of B vector. You know modulus of B vector, right? Square of the components, sum of the square of components. So square root of 2 square is 4, minus 1 square panna 1, 5 square panna 25. Next step solve panna minus 10 by root 30. That is the projection of the given vector. Okay, so the required projection is minus 10 by root 30. Similarly third one also you can do. So it's very simple. Same thing we are going to do. Find the A vector dot B vector and multiplication, and then find the answer. That's it. That is the required projection 9 by root 21. So that's all for today class. We have completed exercise 2.1. Thank you. We'll see you in the next class.